Hi, friend. Welcome to a Water Connection, a space created to learn, connect, and multiply the power of a conversation to give visibility to the water industry. I'm Jess Borges, a passionate human that believes that you should increase your water curiosity. Welcome to this new episode. Today, I'm virtually sitting with Julian Briggs, who has joined us to explore the basics and the exciting future of wastewater treatment. Julian is Aurecon's Design Director for Water and Wastewater Treatment, with over 20 years of experience in the design and optimization of wastewater treatment plants. He has been involved in major water infrastructure projects in Australia and New Zealand, implementing innovative treatment techniques in design, construction, commissioning, and early operation of this important infrastructure. We're very excited to have Julian today with us to explore this important component of the water cycle. Welcome to a Water Connection, Julian.
Thank you so much, Jess. Really appreciate you having me on. I've spent, it's actually closer to 30 years in wastewater treatment now, so I'm pretty passionate about it and very happy to share.
Oh, great. This is going to be a great chat then. Julian, wastewater is part of our lives on a daily basis, and yet many people might have never thought about this. Could you explain us in simple terms, and let's just start completely simple. What happens after we flush the toilet?
Yeah, it's interesting that many people probably don't really give it a lot of thought, and I think that's probably the hard work of all my forebears that put a lot of the wastewater infrastructure into cities to make it easy for people to forget about. But what happens is we have a whole network of carrier pipes. So from each house, there's a pipe that takes your wastewater to a common sewer. And from there, it usually runs downhill via gravity to a low point nearby. And then we have a series of pump stations, and we pump that wastewater through to a treatment plant. So each area will have a treatment plant. Some are smaller, some are really large here in cities like Sydney. And there we treat the wastewater so that it can either be reused or sent out to the receiving waterway.
Yeah, that's perfect. Yeah, that's exactly how it works. And I think you touch on a really good point that we have touched already with some of the guests. And it's like, we do such a good job that people don't have to think about water. And in this case, wastewater. And usually it only comes out when there is a problem. But then the idea of these conversations is really understanding what's behind and who is behind all of this work that is happening there. And why, Julian, what do we need to treat wastewater? What is in this wastewater that we need to get rid of?
So I think the starting point of wastewater treatment was around sanitation, so that it's around protecting public health for people that use the waterways and eat fish from the waterways, but just also the natural environment. So if we start off with what we call pathogens, which are sort of viruses and bacteria that do pass through humans, particularly when we're sick, they then get passed into the wastewater. So one of the aspects of treatment is to treat for those pathogens and reduce them to the point where when we discharge our wastewater back into the environment, it's then safe for people to use those waterways. The other elements, there's what we call carbonaceous material, natural organic material in wastewater that provides an unnatural balance of food, if you like, to the plants and vegetation in receiving waterways. And similarly, there are quite high concentrations of nitrogen and phosphorus. And particularly when we put that nitrogen and phosphorus into rivers, they tend to promote heavy growth of algae. I'm sure if you've been to you've seen pictures of inland waterways, particularly when there hasn't been much rainfall, and you see the whole surface of the river goes green. And so what happens is the algae grows and forms almost like a mat over the top of the river or waterway, and actually kills off a lot of the natural vegetation, but also fish and other biota in the rivers. So it's really about removing those elements and getting it back to a concentration of those elements that the receiving waterway can handle without impacting it too much.
Yeah, okay. And are those components and those elements that can grow a lot in the natural ways, they're coming as well from human, like from the human part of wastewater, or where? Yeah, okay. So that comes from ourselves as well as the
Yeah,
pathogens.
yeah. So the nitrogen is a natural part of urea, which is something that humans produce,
Yep.
um, and the organic matter comes from humans, but also from things like food waste. When we run food scraps down the drain, you might also have coffee grinds, other things like that. So some of the older generation will remember, and particularly other countries have what we call incinerators. So in some countries, it's common to actually grind up your food waste in the sink and
Oh
push it
yeah.
down the sink. But all of that goes to the treatment plant. And then
Okay.
the phosphorus, interestingly, so phosphorus is was historically used in a lot of detergents. So now we have what we call phosphate-free detergents. So we're actually reducing the amount of phosphorus that's mined, but also that comes back in our wastewater. So I'd certainly encourage people to use phosphate-free detergent if you've got the choice, because it's definitely better for the environment.
That's true. Yeah, I was initially thinking only what comes out of our bodies, but like really, our food when we wash the dishes, when we wash our clothes, and then that's even not even going into any of the industrial waste that can also go down those drains. That, yeah, there's quite a lot of components that go there into the wastewater treatment plant, and
Yes.
once it gets there, oh yeah,
Showering as well, and things like when we wash our pots and pans, oil and grease comes off the pans. We get quite a lot of oils and greases in food, so that goes down with that waste as well. And there are some other emerging contaminants that people are starting to hear about. So things like cosmetics, even pharmaceutical products. So people that are now taking, because people are taking a lot of medicines, some of those pass through. Part of that passes through the body and actually ends up in the wastewater. So there's all
yeah.
sorts of components that we're now looking at beyond just those main nutrients.
They're the main ones, sure. And then once the water or the wastewater gets into the treatment plant, what are the main processes involved there to get rid of all this assortment of substances that we have just been talking about?
Okay, so I'll try and take you through the various steps, and depending on where the treatment plant is and how sensitive the environment is, some of them have more of these steps as we need to add them. But the first step is what we call preliminary treatment, the first stage, which is a sort of screening process and removal of grit and sand. So that's what really capturing larger sort of rags and paper and other plastics that might come through. Or you get kids' toys and all sorts of things that end up getting flushed, and they
Yeah.
get removed at that stage. So that's a really important step because it protects the downstream treatment. And then some plants have a settling stage. So that's basically a large settling tank which allows some of the heavier materials to settle out and form what we call sludge, which is actually a really valuable commodity because we can treat that and produce a natural biogas from it, which can be used to produce electricity. So there's often a settlement stage. And then one of the main treatment steps is a biological process where we actively grow a group of biomass that treat the wastewater. And that's the main removal of that carbonaceous material and the nitrogen from the wastewater. And it can also be set up to remove the phosphorus. And so we actually grow biomass in big tanks. We add air to it, we bubble air through it, and run it through a series of different cycles, which remove these nutrients. And then we run it through another set of separation or settling to keep that biomass in the treatment plant, and then have relatively clean effluent. And then, if we need to, there's a sort of post-treatment after that, which is usually some sort of form of filtration. Sometimes we need to add chemicals to remove that phosphorus. and of course disinfection. So I mentioned at the beginning the pathogens. So on the back end, we usually have some form of pathogen removal. Chlorine is still one of the most commonly used ones, and very effective. But we also use UV disinfection, so ultraviolet light. If you pass ultraviolet light through wastewater at the right levels, you actually kill off or disable pathogens in the wastewater.
Yeah, okay.
Hopefully that
And is
wasn't too
that
much, but those are the main
no?
steps.
That was no. I can remember pre-treatment and then settling and then biomass,
Yep,
filtration, and then
yep.
also
And then
disinfection like
disinfection.
chloron
Yep.
and all of that. Yes. No.
And then
See,
off
I
to
get
the side of
it.
that, so that's the main water that goes through, and that produces our clean water. And then off to the side of that, we have both those settled solids at the beginning, but also that biomass that we grow. Because we have to control the population, every day we remove a proportion of that biomass, and that then goes
Mm.
off for treatment. So we also produce a biosolids waste. So it gets treated, stabilized. As I said, we can produce a biogas from it, but then the final product is stabilized. And in Australia, most of that ends up going onto lands for agricultural beneficial reuse. So
Yeah,
those
that
are
was one of the
still
questions I had. Like, you get kind of the cleaner water on one side, and then what is left, then you try and also to just kind of use it. So that part of the biogas, so that comes from like the settlement part, like everything that is heavy goes to the bottom, sludge, all of that, and then
Mhm.
is it like a burning that to create that gas, or how is that part of the process work?
So there's lots of different ways of treating those
Okay.
solids, but the biogas in particular is done through a digestion process, and really not that different to human digestion. Hate to bring it back to basics, but effectively we grow another type of biomass in what we call anaerobic conditions. So that's without air. So we have
Yeah.
these large tanks where we mix the biomass, we grow this population, and when you give them this solid food, they actually break it down from that sort of carbon-based material into methane and carbon dioxide. So we
Okay.
get
Yeah.
a biogas, which is about 60% methane. So if you look at, say, your natural town gas or sort of a propane cylinder, they're normally up at around 98%. Say your town gas is 98% methane, so very pure. We get
Yeah.
about 60 to 65% methane, but you can still use that. You can still use it to run engines. So often we then run that biogas through what we call cogeneration engines, which produce a combination of energy and heat that can then be used to heat that process that produces more biogas for us. So
Yeah, okay. Yeah, I was
it's
gonna
a
ask
process
that.
that's been around for a long time.
Yeah, kind of using that same gas that is produced, but to fuel parts of the process. Yeah.
Yes.
Related to that, I had a question. Is this in general wastewater treatment, is that an energy inject intensive process? Like, is that something that requires a lot of energy to run?
It is quite energy intensive. The biggest component, well, probably one of the biggest components, is all the pump stations of moving the water around. So
Yeah, that's right.
one of the things that we're looking at for bigger cities is actually moving to smaller decentralized treatment plants, not super small, but just there tends to be a history in really big cities of taking the wastewater away from the population. That came from those early days of protecting public health. So you would sort of carry the wastewater quite a long way away from the town for discharge. And what's happened is as our populations grow, we kind of catch up, and suddenly you've got people growing all around the treatment plant and lots more wastewater. So um, those pumping costs are high. The other big cost is that aeration of the wastewater. So we run aeration blowers that compress air and push it down into the base of these reactors that have the biomass. And that's probably usually about half to 60% of the total power
Wow.
demand. So there are lots of efforts. I mean, a lot of myself and my colleagues are looking at ways of trying to do that more and more efficiently and finding ways to reduce how much energy we put into our processes.
Yeah. That's certainly something that is a focus for the industry, and I'll go back into that in a minute as well. I wanted to ask, do the conditions, because we talk about the beginning of all the different things that come in the wastewater, do those conditions change a lot over time? Like in a particular location, I know between different locations might be quite different, but in a particular location, does that like what is in the wastewater changes a lot during the time? That was one part of the question. And the other one is like, does that mean that you have to tweak and adjust the process all the time? Because, yeah,
It's a great question. Look, the we we talk about the different types of wastewater. So one of the terms we talk about is domestic, which comes means from people's houses, the general
yeah,
population, people living at home, whether they're in blocks of flats or homes, whatever. That's usually pretty consistent. It tends to change in broad terms. Only tends to change over years. We do
yeah,
see some difference between dry years and wet years. So as people conserve more water, so maybe they're having shorter showers and all these sorts of things, which is absolutely what we should be doing, and our water agencies are recommending that. So what that can do is mean that what comes to the treatment plant becomes slightly more concentrated because there's less
concentrated, yeah.
water that's carrying it. But generally, the overall mass of what comes from homes doesn't change too much. Our behaviours don't change too much. We do see a what we call diurnal or hour-to-hour variation. So obviously, we don't get much wastewater at night, so we get very low flows. And then there's the kind of morning tide where everyone gets up and they have their cup of coffee and their shower and they get ready for work. And so we see a big flow peak coming through in the morning. And then similarly, we get another peak sort of late afternoon to early evening when people come home. And that depends on which catchment and the size of the catchment as to how variable that is. What does vary a lot more is sort of local industry. You might have some local production that is discharging to sewer, and we have what we call trade waste agreements with most of those industries, particularly the larger ones, to regulate what they put to sewers. But we can see where some of those treatment plants have large scale production. It might be soft drink manufacture or something like that. And so that can give us quite variable loads into our treatment plants, which can be a bit challenging.
Yeah, it could. It would be because industry is like is a whole other kind of scale of things and a scale of wastewater. You mentioned briefly there that they have to comply with a certain kind of type of wastewater that they release into the system that you well let's talk Sydney water because you're in Sydney, like they need to do like a pre-treatment depending on what they do. Is that how it works? So like in case of that whatever wastewater they have might be like having too much things in there.
Yes, that's exactly it. So the trade waste officers from, if it was in Sydney, from Sydney Water would go and talk with that industry, and they would work out what's in that wastewater and whether the treatment plant that it's going to can handle that. So they would allow them to discharge certain loads in, but definitely they're very tight on what we call toxic materials. So obviously things like heavy metals. There might be
Yes.
if you've got say a place that's doing metal plating or something like that. So it might have heavy metals associated with plating the steel or the iron. We don't want that coming down our sewers because it can have an impact on that biology. And so they're fairly careful with those sorts of things, in which case that industry may need to do some sort of separation of that waste or pre-treatment of it, as you say, on site.
Yeah, yeah, that makes sense. Yeah, and now this is kind of what happens with water before it reaches the treatment plant. What is left or what the product is of a wastewater treatment plant? Does it need to be the same all the time? Like, is there a certain kind of set of conditions that you have to just deliver your water into the natural body, or does that also change depending on site to site?
Look, it definitely changes from site to site. For example, Sydney is probably somewhat unique at the moment in that they had just the screening and that primary stage treatment way back in the sort of 60s, 70s, even early 80s. And at that point, that was being discharged what we call near shore, so close to the beaches. And that was definitely having an impact on the water quality. There's a lot of surfers complaining, even getting ear infections and other problems like that, getting sick. So at that point, they built what we call deep ocean outfall. So it actually discharges that treated wastewater up to about 5 kilometers offshore, where it goes into much deeper water and gets diluted very effectively. So those treatment plants only have primary treatment. When we go further inland into our rivers, we're very much looking at that tertiary treatment. So it's the primary treatment, the biological removal of nutrients, then filtration and thorough disinfection before discharge. And actually, parts of the Hawkesbury Nepean system, or particularly the Nepean River, which goes around Sydney, has some of the tightest discharge limits in the world for both nitrogen and particularly for phosphorus, because of the issues in the past that we've had with algal blooms particularly during drought years. So yes, we very much, it's a process of looking at where we can put the wastewater, what capacity that water has to take that waste. And generally we are relying on some degree of dilution of our wastewater in the receiving water. Although in the case of the Nepean, we're actually trying to treat it almost to the background river water quality now, so that it has minimal impact. So yes, and one thing I should say as well, I mean, the other thing that we can do to reduce the impact of discharging is to reuse, and it's something that it's a real passion of mine is trying to promote how we can make better use of water, because you've already had a great discussion with Sally Williamson about treating water, and our history has tended to be we wait for it to rain and we either get water from lakes or groundwater, or a river, we treat it through a treatment plant, we use it once, put it to a waste plant, and then discharge it back into the environment. So it only gets used once. Whereas if we take that water, we can use it for irrigating lands, golf courses. We can treat it for reuse in our gardens, what's called third pipe, or for toilet flushing and washing machines. And we can actually treat it to exactly the same level as drinking water. There are many places in the world where you can actually recycle the water, purified, recycled water, back into the drinking water network.
That's it. Yeah, that's true. And I had a question on that as well, because it's truly making a cycle out of the water again. Like, it is a natural cycle as it is, as it always happens without our intervention. Then it's time, I think, as well, like to move on into having that cycle implemented in what we do, instead of like a line of like, yes, you say I treat it, I consume it, I treat it again, and then there you go. I don't need to see you anymore. When there are like so many uses, as you say, in different levels of like, you can reuse it for irrigation or for other purposes that really we don't need completely potable water. And there is the other kind of option as well of to have it like purified recycled water, which is something that is still we have done it over, and like we have done it. Water hasn't really been created out of nowhere. So like, water is a cycle anyway, so we may as well use it as a cycle.
It's a natural cycle, and Australia is, I believe, the driest continent, and obviously we tend to live around the shores. Water is the drinking water, what we call potable water, so the non-seawater, is a very limited resource. So we have lots of seawater, and one of the options is to actually remove the salt from seawater to produce more drinking water. But it's actually that's one of the most energy-intensive processes. Unfortunately, to date, we haven't come up with a way of removing salt from seawater really cost-effectively in large volumes. There are lots of really cool innovations at smaller scale, for household level, but for large cities, it's very expensive. And again, it's not just the treatment, it's all the pipes. So the more we take out of the sea, we've got to take it from the sea, treat it, pump it inland, use it, and then use more pipes to bring it back to the treatment plants and discharge it back into the ocean. So lots of treatment, lots of pumping. So really what we're promoting is saying, well, we have to use water more than once while we've got it. And it's actually a lot
Yeah.
more cost effective to do that. And just using it for appropriate things. We can also use it for industry, because often we can treat it to any level. It can be higher than drinking water quality. So in Singapore, they use it for their semiconductor industry, for instance.
Mm.
So it's an evolution. In Australia, so Perth injects very highly treated wastewater into their groundwater network, and then they draw it back out for their drinking water. So that's been going for a few years now. They did 10 years of trial and working with the community on that. And then once they had tested all the science and got everyone on board, they've been doing that very successfully now for at least 6 years. So, and they've just expanded that system. So I think that's the
Yeah.
next important thing. You look at a city like Sydney. I mean, I heard once there's probably a sustainable population for Sydney, particularly in terms of water and agriculture, was probably only about 2 million people. And we're above 5 and we're heading towards
Five.
6.
Yeah.
So at some point, you have to say, well, where's the water coming from? It's the same area of land that we all live in. It's the same amount of rain that falls. We can't just magic the water out of thin air. So actually, we start
Make water.
bringing
Yeah.
water up from other areas and we start building desalination plants. But we have to be smarter about how we use our water.
Yeah, I think it's like a combination of different approaches. Like for certain things, it might be just reusing it, and then when is needed, actually going into the desal path as well. And talking about this evolution of like the water industry in general and the wastewater, we have heard a lot from our audience that this is in constant evolution, and it has a lot of drivers around like circular economy, net zero
Mm.
targets. That's why I was asking about energy intensive, that this is promoting a lot of transformation in the way we think about wastewater. Could you tell us a little bit about that transformation that might have happened on the wastewater treatment process from when you began your career to what now they call water resource recovery center, which is a very very different concept, but like at the same time talks to all of these cycle conversations that we're having. How is that changing? Yeah.
Yeah, look, it's changing dramatically. So I started out, showing my age, but in the 1990s, and a lot of the treatment plants had only been designed to remove that carbonaceous, that organic material from the wastewater. There was very limited removal of nitrogen and phosphorus. There were plants around that were starting to focus on that. Um, and so we then sort of worked on that process of going, well, let's protect the waterways. So developed these processes. Unfortunately, what that came with was that energy intensity and also often chemical addition. And so when we look at circular economy and the generation of chemicals, it's not just the actual chemical itself, it's the manufacture of that, where the raw materials come from, transporting it to our sites, adding that in, and then that also produces more solid material which needs to be processed. So it became more and more intensive. And so what we've seen is an evolution not only of going, okay, well, now we know how to remove those nutrients. Let's think about the energy aspect of that. Can we get to, they often term it net zero, or how do we reduce our energy consumption? And there are plants, particularly in Europe, that have actually got to a position where they can even export some energy. They have a sort of
Wow.
neutral energy use, which is amazing. But it does actually involve quite a lot of technology and lots of
Yeah.
steps. And so even that has embedded energy in producing all the elements that are required to achieve that level of treatment when you look at it from a circular economy.
That's true.
We've looked at atmospheric emissions, so we've moved into controlling odors, but then other emissions from our treatment plants, whether it be methane or sometimes we do have to burn off the methane, so we need to make sure that's clean. Um, and we're looking at how we can beneficially recover the resources, as you say. So obviously, by far the single biggest resource is actually the water. So if we can reuse the water, that's the most important. And then we have biosolids, but there are other materials like we can recover phosphorus from that digestion process. and produce a fertilizer product. But interestingly, economically, because of the cost of fertilizers, it's probably touch and go whether it makes sense economically. But from
Yeah.
an environmental circular economy perspective, I think it's critical we move in that direction because phosphorus is a limited resource and we're using it at a pretty high rate. So it's no different from any of the other limited resources. So I
Yeah, the
think we
other
have to get
products.
better at capturing some of these nutrients.
Yeah.
Interestingly, some of the really early treatment, I've told you about perhaps a more advanced treatment. The other types were more natural. So you can use ponds and natural biomass to do treatment. So a lot of the country towns will have a series of ponds that settle solids and use natural sunlight or maybe sun aided mixing or aeration to do that treatment. And so a lot of research is going into things like treatment with algae, which I find really interesting. So you can remove some of the nutrients by treating them with algae, and the algae takes up the nitrogen and phosphorus. The interesting part is that it actually, instead of needing oxygen to respire, it actually takes oxygen from the atmosphere and produces carbon dioxide. Sorry, other way around. It takes carbon dioxide from the
Yeah.
atmosphere and produces
And
oxygen. So
produce
it's
oxygen.
actually
Yeah.
reversing that greenhouse cycle. Apologies, I got
Yeah.
myself mixed up there. But it's actually, when you look at it, it's actually a really efficient process. Unfortunately, at this stage, it requires a lot of land area, so it's only suited to sort of smaller applications.
Smaller areas. Yeah.
But those are the sorts of things that we're really looking at and going, how can we reduce our footprint environmentally, energy wise, and how can we better recover our resources?
Yeah, and then I guess how can we use things that nature are already offering us there, as those algae and those
Mm.
organisms that have been doing it for millions of years? Then maybe it's hard to do it at a scale of the volumes that we probably treat. But like even if it is in areas where it's a smaller volume, it is worth certainly learning from that and bringing those concepts as much as possible to the largest facilities. Yeah. And Julian, what do you think is the biggest challenge that the wastewater area has coming up?
Wow. Look, I think there's quite a lot of challenges. One of them is interesting because, my focus has been more on the treatment, but we have to consider it holistically with all of the pipe networks. So I think probably the biggest challenge at the moment is aging infrastructure because a lot of our pipe networks, our sewers, and what we call rising mains from the pump stations were put in over 50 years ago. A lot of that infrastructure went in the 1960s or 70s, and it's starting to require more and more maintenance. And as more and more people come into cities, it's putting more and more pressure on that infrastructure. Um, and so that's why I sort of said earlier on, we're actually looking now at whether it's now more appropriate to have more regional, localized treatment where we can then reuse the water. We're not pumping it as bigger distances, so we can
Yeah.
reduce the pressure on these really big sewers that need to take it to our centralized treatment plants at the ocean. And we can actually produce really high quality water, where it's needed in, more at a sort of suburb scale. So I think that's one of the evolutions that we're looking at. And so, yeah, most of our challenges are really around population growth. The other thing is that we've become really efficient. I think as we learn more with our science, is that there are a lot of emerging chemicals and contaminants that are used in manufacturing and all sorts of things. So I'm sure, I don't know whether you've heard about this PFAS. I'm sure a lot of people
Yeah.
have heard about PFAS in water, which are these perfluorinated compounds that have been used, very effective in fire retardants. They use them in linings. Interestingly, they're used in makeup, they're used in food packaging, all sorts of different areas. They use them in sort of the shoe, the moisture repellents for shoes and those kind of things. The problem is once they're produced, they're incredibly difficult to break down. So none of those treatment steps that I just told you about actually break down
Take care of
these
that.
PFAS materials. So they end up
Yeah.
back in the environment. So I think we're going to see more of these types of things. Many countries have banned their use or are, sort of legislating against their use, but it takes time.
Yeah,
People,
well, yeah.
chemists find cool ways of producing these things. They start using them because they can see value to their industry, and it's only later that we discover the challenges we have with them
That
at the
brings
back
us
end when
to,
we're trying to
yeah,
treat them.
yeah, of course. And it also will take time until we find technology to actually deal with them. But certainly, at least attacking in like trying to use them less, and then at least that should help us and in while we find out a solution for it. But yeah, there's great challenges there that you have described. And connected to that, what would be your message, Julian, to young water professionals who might be listening to you right now?
Oh wow. Well, look, I mean, if you're interested in water, just keep on the learning journey. I mean, to me, I got into water. I'm a chemical engineer by training, and I got into water somewhat by accident through a colleague of mine who was a chemist that was doing work for Sydney Water. And I've absolutely loved my journey. I find it so interesting. I mean, water is fundamental to life. It's the basis for life. It keeps us as humans alive. It's the building block of all major cities. I think I was told that Johannesburg is one of the few cities in the world that isn't built on a natural waterway, because it was built for mining purposes. So we
Yeah.
rely on water very heavily. It's a really interesting topic area to get into. It's so broad. My colleague Sally, who is a kind of water microbiologist and by training and background, there's the water resources side of understanding our rivers and catchments and stormwater. And then there's all of the treatment elements. There's always something new to look at and think about. So I find it fascinating.
Yeah, yeah, that's you basically answered to both of my last questions, which is one, what is
Oh,
the message, and second, why do you work in water? So I don't have to repeat it. Like we know now why you work in water, and I love
well,
listening to those stories. Yeah.
I also have a personal interest. So my personal passion, I've been a windsurfer since the
Oh yeah.
1980s, which is kind of an old school sport. But you may see now that there's all these wings out on the water and foils. So I'm out there in either off the beaches or in our inland waterways a couple of times a week, 3 times a week. And so it's really
Nice.
important to me that we have beautiful, clean beaches to swim at, beautiful clean waterways. I go down in Botany Bay near the airport, and so I'm really passionate about protecting those waterways as well, for both my generation, but also for all the people that are moving and coming to Sydney.
Yeah, absolutely. It is. Yeah, water is really basic for all of us, from like survival to like thriving and recreation and many things. So it's quite inspiring to like hear that other side of you as well. So it's great always to hear like how people end up in water from different parts of, yeah, of educational kind of paths that we all took. Julian, thank you very much for your time today. Like this was really enlightening. We learned a lot about the basics, and not so basics and future of wastewater treatment. Thank you very much for those inspiring words as well, and yeah, for all the nuggets of knowledge and the keep learning advice, which I think is part of what this project is doing as well, putting a lot of knowledge out there so people can learn the basics and then just go and dig a little bit more in what they're interested in. But thank you very much for your time.
Thank you so much, Jess. Absolute pleasure. And I really admire what you're doing, getting the water message out there and helping educate people on the importance of water to our community. So thank you.
Thank you. Thank you very much. And to you, my friend, thank you very much for tuning in and listening to this episode of our Water Connection. I hope you enjoyed the conversation we just had with Julian. Follow us on LinkedIn as a Water Connection, and on Spotify or any Apple podcast or YouTube and like all the different platforms where you can listen to podcasts. We are there. So yeah, see you next time.